Number 54, I helped a few people in here yesterday with that. 54 is the first one that we've ever graphed with a vertical shift. So that was kind of a tricky first one here. But if you just graph 2 cosine of x, so what you always do, look at your period, a 2 changes the amplitude, then all of your answers you have to add 3. So this is one that I would actually make an xy turn on. But sine and cosine, your period is 2 pi over b. B in this case is 1, which means that if you're picking those 5 points, they're just the normal 5 points from 0 to 2 pi. So this is pi halves, this is 3 pi halves. And I hope at this point that for sine and cosine we know the pattern. Normally cosine starts up at 1, it goes to 0, it goes to negative 1, it goes back to 0, and ends back at 1. But when there's a number in front, an amplitude change, it's going to change that, right? So if there wasn't a 3 there, we would have like 2, 0, negative 2, 0, back to 2. But the weird part about 54 is you have to add 3 to all that. So if you plug in 0 here, you get 1. 1 times 2 is 2. 2 plus 3 is 5. Because the vertical shift, we're taking that whole cosine graph and we're shifting it up 3 units. Next is 0. Normally this goes to 0, but guess what? We're adding 3 to that. So 0 plus 3 is 3. Then at pi, we go down, normally we go down to negative 1. The 2 means that we would go down to negative 2 plus 3 means that that's actually going to be up at 1. Moving it up 3 units. Pi halves back to 0, or in this case, back to 3, because I'm moving it up 3. And then for cosine and for sine, it should end where it starts, right? That's 1 complete period. If you get back to 2 pi, it should be the same back as 0, which is 5. Which means it's still a pattern. It's just kind of weird because we haven't done these with the vertical shifts. What you have to do on your graphs is you have to label your x and y axis. If you don't label your x and y axis, you're going to miss a lot of points because I need to know what it's going by. So for me, I always just usually label half of it, like, so then it's implied that this is pi halves, pi, 3 pi halves, 2 pi. And I really don't need any negative numbers on my y-axis, but I do need to go all the way up to 5. Show me something, whether you label every one of them, 1, 2, 3, 4, 5, whether you just label a couple of them. Some people in second hour like to do little brackets like the book does, like negative 2 pi to 2 pi bracket, comma, 0 to 5, or negative 5 to 5. I just usually label some points here. But a vertical shift just moves the whole graph up. So it's still the normal cosine graph, still amplitude of 2, but we've just shifted it up. So we're actually going to start all the way up here at 5. At pi halves, it goes to 3. At pi, it goes down to 1. At 3 pi halves, it goes back to 3. And at 2 pi, it ends back at 5. And if you look at this, this is what 1 period of cosine looks like. It's just shifted up. If you think about, we shifted up 3 units, so that line at 3 is like the new x-axis, which is why it's with 0 points. And remember that cosine is even, which is why I always just graph the negative, because I know it's going to be the same. Back up at 5. And on your graphs tomorrow, you have to graph at least 2 periods. So if you only graph 1 period, you're not going to get all your points because you need to graph 2 periods. Yes. Yes. Have it there. Tangent and cotangent and secant and cosecant. You have to know the asymptotes. If you don't get your asymptotes right, again, that's going to be an issue. So starting for those, step 1 is you have to know for tangent, the asymptotes. I do negative pi halves and pi halves. Sam likes to do pi halves and 3 pi halves. It always works as long as you pick 2 in a row. I just always do the negative. But you have to set that equal to 2 consecutive asymptotes. So for me, I'm going to do negative pi halves and 2x equals pi halves. And when you solve that, that tells you where your first 2 asymptotes are, and then you have to equally space them to get the next one. And again, for tangent, you need another set of asymptotes because you have to have 2 periods graphed. Do the algebra right here, kids. If you divide by 2, that 2's on the bottom, so that's going to be at negative pi force and at pi force. So when I label this at negative pi force, so this would be at pi force. Notice there's a space in the middle of that, which means when you're labeling your next asymptote, try to make it equally spaced. You would skip the next one, and then this would be your next asymptote. And I want you to label that. I want to know that you know what that next value is. So you could either add the period to this, or I just always count, right? Like if this is pi force, 0 to pi force, the next mark in the middle would be 2 pi force, which means this would be 3 pi force. That works for anything. You just might have to reduce it. Let's say this was pi eighths. This would be 2 pi eighths. This would be 3 pi eighths. This was pi tenths. This would be 2 pi tenths. This would be 3 pi tenths. Right? Like you can just count by whatever it's going by. And for me, I start with my asymptotes. It gives me the bounds there. So I can put in this asymptote. I can put in this asymptote. I can put in this asymptote. Tangent should always go through 0 because we don't graph phase shifts, which means at 0, the tangent of 0 is always going to be 0. So if it's not, you should probably check. Maybe your asymptotes are wrong. If you don't know what happens from here, I always say pick one point. I hope at this point you know that tangent makes that S graph shape. So halfway in the middle is 0. If you go halfway between 0 and pi force, that would be pi eighths. And the tangent of 2 times pi eighths would be pi force. And the tangent of pi force is 1. You must make 3 points for me on this. Right? 1, negative 1. Don't just wing it from here because people don't do a very accurate job if they just make 0 and they just draw the line. I want to know that you know where that next point goes to. So since there's nothing in front of this, that's why it just goes to 1 and down here back to negative 1. If there was a 7 in front of this, it would go all the way up to 7 and down to negative 7. Whatever number's in front, just like the amplitude for sine and cosine, that's how much you're stretching it. Big mistake people make is they take this 2 right here and they think that means stretch it up to 2. Right? That has to do with your asymptotes, not your stretching factor. Make sure I see those points. And that's 1 period of tangent, which means you only have to make 2 of them. And once you get 1, you just repeat the pattern. And again, super important that you're labeling the x and y axis. You don't label the x and y axis, you're not going to get a whole lot of credit. Questions about that? Number 58, cotangent, again, asymptotes. Definitely on the calculator part of this test, like the whole first page is graphing. Like I just have graph after graph after graph after graph of you finding your asymptotes or you finding the period and you picking these values. I hope that we're doing better with this than we were at the beginning of this chapter. But for me, when I see cotangent, cotangent has sine on the bottom. Sine is 0 at 0 and at pi. Which means when I solve this, I get x equals 0 and x equals pi thirds. I really like cotangent and cosecant because they're always going to have an asymptote at 0 because we don't do phase shifts with our graphing. Which means I know one's at 0 and then I can just equally space, and usually people count better on these. Something else to notice about this as you're doing it, there's a negative, which means it's going to flip that S shape. There's a 2, which means it should go up to 2 and down to negative 2 when you're doing that. So that's easy things that you can go back and check before you turn your test in. Did I graph this the way it's supposed to be graphed? If I make this pi thirds, what would the next asymptote be? It's the distance of pi thirds, so if I go pi thirds away from pi thirds, that's 2 pi thirds. Label it. That's really all you need to do. but I have this marked over here, so I'm going to mark this as negative pi thirds just to show you that it just keeps repeating itself. Number one mistake that I see with cotangent is people put an asymptote here, they put an asymptote here, and then they graph it like would be tangent, like they put the 0 right here, right? It's kind of hard to see sometimes with your pencil, but there's another asymptote along that value, and so don't forget that part. And again, if you get stuck, pick the point, like do the math. That's why a lot of these graphs are on the calculator part, because I don't want you to miss a problem because you don't know what half of pi thirds is. But plug it in, like that's the go-to method, just like with everything. If you don't know how to graph it, make an XY chart, plug in a bunch of points, and hopefully you'll get the right shape. Hopefully you know the shape, and so it'll help you make sure that you're doing it right. But just like tangent, halfway in between should be 0. If you don't know which way it's supposed to go, especially because the negative kind of throws you off, pick that first point. So you got to do the math here. Half of pi thirds is pi sixths. Half of pi sixths is pi twelfths. And it should be, when you plug it in there, that you get pi fourths, because tangent and cotangent of pi fourths is always 1. That's why we picked that as our first point. And it works. Negative 2 of cotangent of 3 times pi twelfths gives you pi fourths. And normally, cotangent goes up to 1, and over here it goes down to negative 1. But that negative 2 means that we're actually going to stretch it by a factor of 2, and we're going to flip it. So this is actually going to go down to negative 2, and this is going to go up to positive 2. And just because your y-axis is going by 1s, you still have to label it, because some people only put 1 mark on their graph every time, and they label it whatever the high point is. So like some people only mark 1 slash and they put a 2 there. So make sure you're labeling this. But this should go down to negative 2, and this side should go up to positive 2. And again, I need to see all 3 values there. And then I'm just going to repeat it. Down to negative 2, up to positive 2. And that's all you really have to graph. But I told second hour to tell you the same thing. If you fill out this graph like I did, don't leave that blank. Either erase that asymptote so that I don't see that you left part of your graph blank, or just fill it in. Like whatever you label your x-axis, fill it up. Because right now, if you let your answer like this, it looks like there's not part of your graph here, when we know there's another one of these right here. So if you make 3 periods, draw 3 periods. Questions about that? Secant and cosecant, if you get the asymptotes right on that, and you know that they're up and down parabolas, secant and cosecant are the fewest amount of points that I make you pick, because I don't care about I only care about that you get like the vertex of each of those parabolas, and then I don't care after that as long as your asymptotes are right. So secant is over cosine, right? So it's the same as tangent. So x over 2 equals negative pi halves, and x over 2 equals pi halves. Do the algebra right. It's so frustrating when you miss a problem because you just don't, because you divide by 2 instead of multiply by 2. So you get x equals negative pi and x equals pi, because the 2's cancel out. And this one's a little bit trickier to get 2 full periods in. If I do this as negative pi, and I do this as pi, should make those closer together, but that's okay. Again, just like tangent, you skip the one in the middle. So if this is pi, I would skip the one in the middle, and my next asymptote would be here, which would be where? 3 pi. And I'm totally out of room here, but I would skip the one in the middle, and then where would my next asymptote be? 5 pi. So let's see if I can fit this on here or not. I don't know. Let's see what I have here. So I have 1 at pi, negative pi, and 3 pi. For some reason I wrote gigantic on this. I guess I'm going to stretch mine back this way. I'm going to erase this. wish you had this little magic thing on your paper that you could just stretch your values on. So I'm going to make this skip the one in the middle and make this negative 3 pi. And you might say, why are you making so many values here? For secant and cosecant, the period is 2 pi normally. So you have to have 2 sets of asymptotes to fit those in there. So just made my points all close together, but that's okay. So normally, this is like cosine. Normally, cosine starts up at 1, right? Which means secant starts up at 1. But what does this negative 2 mean it does to my graph? It flips it, and where's it going to be? At negative 2, which means my first point would be at negative 2. And if you get your asymptotes right, all you have to do is make that point, and then show me that you know it's like flipping the cosine over, so it's just a parabola. And that's it. It's the only point you have to make. You can pick other points if you want, but there's no need to. And if that one goes down, what happens halfway in between these asymptotes? It goes up to positive 2. And it's going to look like that. That is one period. It has to have 2 parabolas, because a period is when you get every value and then it starts repeating itself. It doesn't start repeating itself until after 2 sets of asymptotes, which means I still haven't graphed 2 periods in this, have I? Because this one would flip over and go back like this, which means this one, if I squished in here 4 pi and then 5 pi, even though this is not equally spaced, just humor me for a minute, there'd be another asymptote, 5 pi, and this would go down. So as long as you have 4 parabolas drawn, I'll count that as 2 periods. Okay? Maybe better space than mine. I'll give you the same type of graph paper that I did on this quiz, where it's just squares, so you can make your x and y axis however you want it, but it'll be nice squares so you can make them evenly spaced, unlike mine and normal. Alright, there's one more graph and then we'll go a lot faster. Try not to get super distracted by all these other answers up here. I'm going to cover this up down here. Those are 61 and 62, but just hold on. I like 60 because it has pi in it, and I like to remind you that sometimes your x-axis might not go by like pi halves or pi or 2 pi, because if pi's up here, when I do my asymptotes, I would set pi x equal to 0, and I would set pi x equal to pi. And when I solve that, I get x equals 0 and x equals 1, which means your x-axis is just going to go like 0, 1, 2, 3, 4, no pi. So if there's one at 0, there's one at 1, where's my next asymptote going to be? 2 and 3, because they're equally spaced. Negative 1, negative 2, negative 3. I need all those. Okay. Like overcompensating for not making enough last time. I can do this. If you get your asymptotes right, for secant and cosecant, all you have to do is know where that parabola starts, and it just is going to start halfway in between at whatever number's in front of that, like whatever that amplitude would be on sine and cosine. So halfway between 0 and 1, it should start at 1, and it's going to go up. There was a negative in front of that, that means it started negative 1, because it flips over. And then halfway between that, it's going to go down to negative 1. Because it's kind of doing the opposite of what sine does. Sine starts here and goes up, it goes here and goes down. That's one period. I'm going to keep going. This side was just going to flip and repeat itself. This side's going to flip and repeat itself down here, and like this, and like this. Which is why I think the asymptotes and knowing how to find your asymptotes is the most important part, because from there you're just drawing in parabolas. And that's, that's like 3 periods I got there. But questions about that? My advice to you is if you want something to study tonight, read draw graphs that you have the answers to. Either graphs that we've done in our notes, graphs that are from this, graphs that are to odd problems that you can look at the back of the book and check. Do graphs that you can check in the back of the book and make sure you're doing it right, because that would be a great way to study.
So is this one like the last one where two parabolas is one period?
Yes.
So you have to do 4.
Yes. Because one period is when it starts repeating itself. So it doesn't start repeating itself until after 2 of them. So yes, secant and cosecant, you have to have 4 parabolas. Tangent and cotangent repeats itself every time, so that's why you only need 2. From there, 61, 62, and 65, they ask you to list the period, the amplitude, the phase shift, the domain, and the range. They don't ask you for the vertical shift, but I threw that in there because I'm going to ask you for the vertical shift. And remember, the vertical shift is just like the very first one that we did, 54. If there's a number added or subtracted on the outside, then that would be the vertical shift. None of these have a vertical shift, which is why they didn't ask you for it, but I had some numbers written on here. Like, if this had a +3 out here, then the vertical shift would be up 3. If this one had a -2 out here, then the vertical shift would be down 2 units. And we talked about that. There's just none of these have vertical shifts. Someone asked me yesterday about the domain and range. I'm not going to make you find the domain and range, but for sine and cosine, the domain, it's always all real numbers because there's no asymptotes. It's a smooth curve. And the range is actually pretty easy because the range is just your amplitude, negative, positive, right? Like you do range every time you make your graph. You know that the high and the low, which is why they asked you that. But period, you got to know. Period is 2 pi over b. Simplify it. Amplitude is the absolute value of A. Phase shift, the only thing I'm going to ask you about phase shift comes from these problems. If I give you a function, tell me the phase shift. And the phase shift formula is C over B. And notice on number 61, there is no C value. So 0 divided by B is going to be 0. And if you wrote 0 here, that's the same as none. I just wrote none because it wasn't a phase shift. But it would be a phase shift of 0. Number 65 is the one that has a phase shift. And notice that when we write this out, it's Bx minus C. So when you do the phase shift, it's like you're taking the opposite sign of C. So the answer here is 1/2 C over B, not negative 1/2. Questions about those 3? That could be, I just give you that on a calculator or no calculator. 69 and 70 are definitely calculator problems, which means they have to show up on the calculator part. Make sure you pay attention to the directions. Like on 69 and 70, the directions said give your answer in both degrees and radians. Don't miss a point on your test because you only give me in radians and you don't give me in degrees, or you give me in degrees and not in radians. Make sure you're in the right mode. You can tell I did this one first with my calculator, and then I was in degree mode, so then I did degrees first the second time. Questions about those?
Round is like a fancy field for like instead of like quarters
the directions will tell you what to round to, and so like on these they didn't tell you what to round to, so obviously we're going to have different rounding. But on the test, if I want you to round to a certain one, I'll tell you. If the directions don't say what to round to, then I can't mark you off for rounding. So if you do 2 and I do 1 or whatever. But I think I usually try to put what to round to just so that it's easier to grade. And remember, it goes tenths, hundredths, thousandths. Struggle with that. And then 10,000ths, but I don't think I've ever written round to the 10,000ths. I just say round to 4 decimals. So, not trying to trick them. All right, this one's going to go a lot faster. Here are all the answers for 71 through 88. Really, all of these should be able to be done without a calculator, and we'll talk about maybe 86 and 87 and 88 in a minute. But go through and check those, so then we can talk about what questions that you have. Because this is really, besides graphing tomorrow, this is the kind of stuff you're going to see on the no calculator part of this test. The stuff of solving these equations, doing the inverse trig stuff without a calculator. So if you use a calculator on these, on the test, you don't get a calculator. So I'll give you a minute to check these, and then we'll go from... And actually, let's talk about questions from 82 up first, and then we'll focus on those bottom ones. So when did you get as an answer?
I had 2/3.
So I think some coordinates. So the cotangent of x equals negative square root of 3. Did you change it to tangent or did you leave this?
Because I have 1 over tangent, so I probably forgot to switch back to.
Yeah, maybe. Like you can change this to tangent, but for me, tangent and cotangent is kind of the same amount of work if you're doing unit circle. So like if you leave it as cotangent, remember that this is like what, x over y from that unit circle. Or if you switch it to tangent of this would be 1 over negative square root of 3, right? Whichever way you want to think of it, which would be y over x, right? I don't care which way you think of it, but you got to make sure you have your points right. Between 0 and pi, you should be able to tell me that it has to be in quadrant 2, because tangent's negative in quadrant 2 and positive over here. So it's going to either be 5 pi 6 or 2 pi thirds, just making sure that your ordered pairs are right. So if we look at this ordered pair, that's negative square root of 3 over 2 1/2, right? So if you're doing tangent is y over x. So if you do this one, 1y over negative square root of 3, like that is the right one. If you do cotangent, x over y, so I think maybe you just switched up your numbers maybe.
That's supposed to be 1 over
Radical 3 over, yeah, because you're right. The tangent of radical 3 over 1 would be up there at 2 pi.
So is it easier to like cotangent or like
Tangent and cotangent, I feel like it's the same. It's the same amount of work because you still have to think about it. Y over x, x over y, just depending on which one you want to leave it as. I like changing secant and cosecant back to sine and cosine because those are directly from my unit circle, right? Like sine is y, cosine is x. I do better with those. But tangent and cotangent, I feel like it's about the same amount of work depending on you want to think about it. So just make sure if you change it to tangent that you flip that over. Okay? Other questions up to 82? Deborah. And 80 is secant of x equals 2. So again, this is one that I would change. Secant of x equals 2 means cosine of x equals 1/2. This part is the super important part, right? If this said from 0 to 2 pi, remember that's where you can give me, like there'll be 2 answers. But this is telling you that it's only from pi to 2 pi, which means from pi to 2 pi means I'm in quadrant 3 and quadrant 4. Which one of those is cosine positive in? Quadrant 4, and then it's just either knowing your triangles or your unit circle. So 1/2, I know it has to be 11 pi 6 or 5 pi thirds, and it's just making sure that you get the ordered pair right. Right, so it's, so what is that? Square root of 3 over 2 negative 1/2, and so that would be 1/2 negative square root of 3 over 2. Cosine is x, which is why it's 5 pi thirds. And so that's why this is super important, because you might have said pi thirds. Is the cosine of pi thirds 1/2? Yes, but pi thirds is not between pi and 2 pi, which is why many people just disregard this, but it's super important so that you know which answer to give. Does that make sense? And again, I cannot stress enough, you have to make sure you know the unit circle. If you're going to draw that unit circle out on your test and use that for every problem, make sure it's right, because if you label your unit circle wrong, you're going to miss every problem if you labeled it wrong. So sometimes I think it's just as better just to draw it out as you go, because then maybe if you labeled it wrong on one, you won't label it wrong the second time, but that's just my opinion, I guess. Other questions on those? What about the bottom ones here, which 85, you can just, and 86, you can just, those are from our unit circle, we can do those, right? You just start with the inside and you work it out. But also, on 85, 86, and 88, I gave you those properties that said, if it's in the restricted domain and range, that when you take tangent of inverse tangent, or cosine of inverse cosine, that they just cancel each other out, right? But we talked about, you just work it out. It works out. But what if I gave you 88, which 88 is a little extra tricky. I'll write you a new one in a minute, but I picked this one just to try to, so we could talk about it. What if I put 88 on a no calculator part, and you would freak out because you would say, pi 7 isn't in my unit circle, how am I supposed to do this? Well, if I was doing this, I would have written this as just cosine inverse of cosine of pi over 7. because they took it one step further to make things more complicated. Because is negative pi over 7 in the restricted thing for cosine? What's the restricted thing for cosine? Yeah, 0 to pi, right? Inverse sine and inverse tangent is negative pi halves to pi halves, so it would have been in there. But for cosine, you're only supposed to be able to cancel out if it's between 0 and pi. So when I first looked at this problem, I thought, how am I supposed to do that? Because it's not in my restricted value. And the book says, like, they like to trick you and say, well, cosine's even. So an even function, if you plug in a negative angle, isn't that the same as plugging in a positive angle? I won't do that to you. If I gave you this problem, it would just look like this. And the reason that you can do this is because cosine's even, but just know I won't do that to you. But now, is pi sevenths in between 0 and pi? So since that is in between there, even though I don't know what the cosine of pi sevenths is, I can say that property cancels those out, and that's why the answer is pi sevenths. And so my advice to you is if you see a question tomorrow without a calculator that's not in the unit circle, I'm not trying to trick you. Well, maybe I am trying to trick you. But you should get it right, because all you have to do is think about, is it in the restricted domain or range, depending on how it's written. So what if I wrote inverse sine of pi fifths? Pi fifths is not in my unit circle, so I don't know what the sine of pi fifths is. But is pi fifths in the restricted range of inverse sine? Which means, what's your answer here? The answer is just pi fifths. What if I wrote this, though? What if I wrote the sine of inverse sine of 7.6? Is 7.6 in the restricted domain for inverse sine? Because what's the biggest and smallest that sine can be? Pi halves to pi, that's the angle part, but what about the answer part? This is the answer part. That's cosine. Negative 1 to 1, right? Negative 1 to 1? Negative 1 to 1. That's bigger than 1, which means what's the answer to this problem? Undefined. We did one like this undefined one in our notes, and people said, well, I'll know on the no calculator part if it's not in the, like if it seems like it's not in my unit circle, I'll know to just put undefined. Well, I found a way to not let that happen, because sometimes you'll just cancel out if it's in the restricted domain or range. If it's not in the restricted domain or range, you'll put undefined. I'm telling you, I'm putting that on there tomorrow to see if you can think about it without a calculator. Because obviously with the calculator, you could just type it in your calculator. Angel.
Okay, could you explain 87?
Yes, I'm going back to 87 now. 87 and then whatever the next one is with the x are done the same way. And the thing is, 3/5 is not in your unit circle. You can't just cancel out tangent and sine, which means you have to use triangles. And I think on your test, I even give you a hint on these problems. Like, hint, maybe draw a 3-sided figure. Because I'm hoping that it will jog your memory of like, oh, if this says inverse sine of 3/5, that's like saying the sine of some angle equals 3/5. So I could draw a lovely little triangle. I could label one of these as theta. And then I know that sine is opposite over hypotenuse. And then could I do Pythagorean theorem to find that third side? And it's just like the one with the x's, except for it's just numbers. And 3, 4, 5 is a right triangle, so I don't even have to do Pythagorean theorem. But if you did, it should work out that's 4. And then just like the other problems, you use the inside part to get your triangle. And now you actually take the trig function of the outside part. So now I can say the tangent of that is opposite over adjacent, which is why the answer is 3 over 4. And again, I'm pretty sure my directions tomorrow say, or whatever day it's on, hint, maybe draw a certain 3-sided figure. So hopefully that would help remind you that you can do that. And that leads to the next one, 94. It says, find an algebraic expression equivalent to tangent of inverse cotangent of x. Just like that one we just did, the only difference is it's not a number, it's an x value, which means you still draw the picture. And remember, it doesn't matter which one you label as theta as long as you label it right. Cosine is adjacent over hypotenuse, which means you could label that as x over 1. And you should be able to do Pythagorean theorem. I shouldn't leave much room for myself to squish that up there. But Pythagorean theorem would leave me this to be the square root of 1 squared, which is just 1, minus x squared. And then find the tangent of that. The tangent of that, no, what am I finding of that? Yeah, the tangent of that would be opposite over adjacent, which is why they got this over x as the answer. And that could be on a calculator or no calculator part, because really a calculator's not going to help you much on that, but it just depends on which part I put it on. 95 and 96 would definitely be on the calculator part of the test, because I would want you to use calculator to get a decimal answer. So do you have questions on either one of those? Big thing is make sure you know the difference between angle of elevation and angle of depression. Both of these are angle of elevation, right? But maybe go back and look. Angle of depression, probably you could guarantee there'll be one of those. Tomorrow you're not going to turn homework into me because I want you to have it in case you want to look over it again. But Thursday, first thing is you'll turn in your homework. Thursday's Pride Time Day for us, which means we're short in 6 minutes, which means make sure you have your homework together when you come in here Thursday so you can turn it in and you can get started on your test. Okay? Questions about any of this?
So it'll be like
Consecutive asymptotes?
Yeah.
That'll be okay. Did I pass back your last homework quiz in here? No, I still have these other quizzes I should pass back. There's on the bottom of your last one where it said find 2 consecutive asymptotes, like this. That would definitely show up probably on the calculator part, where I make you do the algebra, and you just have to watch your algebra here, kids. There were so many people that started that the right way and then just did their algebra wrong. The idea is you do it just like you do the graphs. Secant is the same as tangent, so you would set that equal to negative pi halves and pi halves, and then just do the algebra there. Subtract pi, and really you're treating that like a variable almost, because they both have pi in them. So it's like taking negative 1/2 pi and negative 1 pi gives you negative 1 1/2 pi, or negative 3 pi halves. And then on this one, when you subtract pi, 1/2 minus 1 gives you negative pi halves. And you're just doing the algebra there to solve that. And they might be ugly answers because I can make you find them, and they can be really ugly, especially if I'm not going to make you graph them. If you can graph asymptotes, you should be able to find asymptotes. Just don't forget to watch your algebra there. Don't be breaking any math laws when you're solving those. Okay, and so those would be good to look over as well. So no new homework tonight except for study. I would definitely recommend looking over your stuff. I'm going to pass back the homework quizzes from yesterday and your chapter or your 4-7 quizzes that I kept from you as Courtney had to take hers still. Okay.